Welcome to Real Civil YouTube channel. In this video, I am going to show you how to model the structure and analyze for the seismic forces. For that, I have taken one PDF uh, on calculation of design seismic forces by static analysis method, and this PDF is prepared by here you can see IIT, VNIT, and IIT Kharagpur. Okay, so the problem statement is given here. We are going to use the equivalent static method, and I'm going to show you. This is the manual solution, and this is the base shear. Uh, we are getting this base shear. I'm going to compare the base shear in Etabs software. So this is the problem statement. Consider a four-story reinforced concrete office building as shown in figure. The building is located in Shillong, seismic zone 5. The soil conditions are medium stiff and the entire building is supported on raft foundation. The RC frame are infilled with brick masonry, and they have given the lumped weight due to dead load is 12 kilonewton per meter square on floors and 10 kilonewton per meter square on the roof, whereas the live load is 4 kilonewton per meter square on the floors and 1.5 kilonewton per meter square on the roof, and they have asked to determine the design seismic load. So this is the plan and this is the elevation. So first I will show you how to model this plan. So open Etabs software and go to file, new model. Use built-in setting metric Indian IS 800 2007 and IS 456 2000. Here, number of grid lines in x direction, the first option. So here you can see number of grid lines 1, 2, 3, 4, 5. Here you can see these are the grid lines 1, 2, 3, 4, 5. So I need 5 grid lines in x direction. In y direction, here they have written A, B, C, D. That means 4 grid lines required in y direction. So it is already 4. Spacing of grid in x direction. So it is 5000 millimeter. That means 4 meter. And in y also it is 5 meter. So you can just simply 5 meter, 5 meter. Okay. Number of stories. This is the elevation. So 1, 2, 3, and 4. 4 stories are there, and ground story is of 4.2 meter. So number of stories 4. Here typical story height. Typical story height means the ground story here, bottom story height is 4.2, and typical story means above that it is 3.2, 3.2, and 3.2. Okay, click on OK. Now we have prepared the grid line as per the required plan. Now we will define material properties which actually uh, in the given problem the dead load is not considered. They have directly given us the intensities which we will take. So just for the formality and for the modeling purpose, we'll choose here concrete M20, and we don't want the self weight to be calculated. That's why I'm putting it 0. Click on OK, and then rebar. Again, I don't want the weight to be calculated, so I'm making it 0. Okay. Now next is section property. Again, they don't have given any section property. Uh, so we'll assume some dimensions. Here I'll give the column 230 by 230, and here I will select M20 grade, 230 depth, 230 width. Yes, column doesn't matter you change it or not, because we are going to do only seismic analysis here. Similarly, add new property for the beam, 230 by 230, 230, 230 beam. Okay, okay, okay. Now I will define the slab also. Add new property. Here I will define the slab of 100. Again, self-it is not going to be considered. Here I'll go with membrane. Okay, now I want to model. Here I will select the option towards the right corner, all storage. Now draw. Here quick draw column is the option. I am at the story number 4, that is I am at the top story. Here I will select the property of the column 230 by 230. I will just drag. So here you can see all the columns are drawn. Now I will select the option for the beam. uh, First of all, or else you can just close, draw, quick draw beams. Here select the beam option and make sure it is all storage. Now you can see all the beams are drawn. Now next we have to draw the slabs. So go to floor, quick draw. Here select the slab, make sure it is all storage and just click. Okay. Now as we have selected the all storage, that means at the base, that is at 0 meter, the slab is also created by this Etab. So here make sure one story and then just select these slabs, because at the footing we don't want any slab, so simply delete it. Okay, and then at 4.2 meter level, 7.4, 10.6, 13.8, at the remaining there is a slab. So this complete our modeling part as per this problem statement. Now we need dead load and live load to apply. So for that, we'll go to define, and here we go to load case. So by default there are 3 cases. Okay, or we will basically go to load pattern. So here I will give the name super dead floor. I will add this, then super dead roof, add, then live load, I will write here floor and live load roof. So this live case I will delete. This dead case also not required. Okay, click on OK. Now here you can see, as per the given problem, dead load 12 kilonewton per meter square on the floors and 10 kilonewton per meter square on the roof. So we have created dead load floor, dead load roof case, and then live load on floor and live load on the roof case. So now we will first apply the floor loads. So at 4.2 meter, select the slabs. Okay, make sure it is one story. Go to next floor, select the slab. Go to next story, 10.6, select the slab. Okay, above this there is a roof, so we'll won't select this. Now we will apply dead load of 12 kilonewton per meter square on the floors. So go to assign shell load uniform. Here make sure it is super dead floor. Load intensity is 12. Click on apply, click on OK. Okay, now here there is option select get previous selection. So whatever we have selected previously, those slabs will get selected. Now we can apply the live load of 4 kilonewton per meter square. So assign shell load uniform. Here live load floor, which is 4. Apply OK. Now on the floor we have assigned the dead and live load. Now go to roof and select this slab. Assign shell load uniform. Now super dead, that is dead load on the roof. So the dead load on the roof is 10 kilonewton per meter square. So 10, apply OK. Now I want the same selection. So select get previous selection. Now here on roof it is 1.5 kilonewton per meter square. So assign shell load uniform, live load on the roof 1.5 kilonewton per meter square, apply OK. Now loading part is over. Before that we will assign the support here, which is fixed support. Assign joint restraint fixed, apply OK. Now the gravity part is over. Now we will go for seismic assignment. So go to define. Here we will define the diaphragm. Make sure it is rigid. OK. Now go to select object type, select all the floors. Now assign shell diaphragm, which we have defined, that is D1, apply OK. Now go to define load pattern. Here we will generate earthquake X direction. Here it is seismic. uh, sorry, I will repeat the step. EQ X, here seismic, and make sure the code is IS 1893 2016. Here, yes. Similarly, add EQXY case. Now here we need to modify these properties. So in our problem, seismic zone is zone 5. That means the value is 0.36. So 0.36. Site, that is soil type, is medium, that is type 2. Here it is given type 2 medium soil. So medium. Importance factor, here importance factor used is 1. Then here make sure the time period should be user defined. So they have calculated the time period in x direction as 0.28 second using this formula, which is available in the IS code. So here 0.28. Response reduction factor are, they have used the 5. So 5. Here make sure it is x direction. Click on OK. Now similarly modify the lateral loads for y direction. So for y direction, the time period is 0.32 seconds. Remaining things are same. Here make sure it is only in y direction. Click on OK. Click on OK. Now the last step is defining the mass source. Just modify this. Here remove these first two options and select the specified load pattern. So as per IS code, we have to consider the full dead load, that is on the roof as well as on the floor. So add live load on floor, as it is 4 kilonewton per meter square, we have to consider 50%. And live load on the roof we don't need to consider, because we don't consider the live load on the roof as per the code, unless and until there are some fixed attachments like machineries and etc. So this much part is required. So click on OK. Click on OK. Now save your model and analyze. Analyze, run analyze. Now we have analyzed the structure. As per this manual calculation, the base shear of 1404 kilonewton is generated. So to check this, we have to go to display, story response plot. Here you have to select story shear. You have to select the case of EQX, sorry, EQX1. Okay. Now here you can see the 1404 base shear is generated. Manually also we got 1404. For individual floor also at story 4 it is 595. If I put my cursor, you can see value here at the down, 595, 1087. So here you can see 595. Then you have to add this. Okay, or instead that you can see the lateral force also. Yes, here you can see 595, 491. Here it is 492, then 240, 239.66, and finally it is 77. It is 77. So this is how you can check for EQX. Also you can check for EQY. You can see here story displacement. You can see story drift. Okay, so all the results are available here. So I hope the concept of seismic analysis using Etabs software is clear. We have validated our results with manual calculation also. Thank you. Thank you so much for watching the video. Please like, share, subscribe the channel. Thank you. Thank you so much.